Hello and welcome. In this video I'm gonna show you how we can use the chain rule to prove that a given function is a solution for a differential equation. Show that the function y equals a times e to the negative 3x is a solution for the differential equation y prime plus 3y equals 0. So we have to prove that if we add derivative of this function, y prime is derivative of this given function, to the 3 times the original function, the sum of these two equals 0. So basically the first thing here we have to do is to find y prime. Y is a times e to the negative 3x. Derivative of y prime is a times, attention, for finding derivative of this function, a is a constant. So you don't need to use the product rule for finding derivative of this function. Write the coefficient, write a, and now take derivative of this function. What is derivative of e to the negative 3x? Derivative of e to the negative 3x is e to the negative 3x times by derivative of an exponent. Remember, based on the chain rule, we have to take derivative of the outside function and then multiply by derivative of inside. Inside function here is negative 3x and derivative of negative 3x is negative 3. So y prime is negative 3 a e to the negative 3x. Now we want to show that y prime, this expression, plus 3 times the original function equals 0. So we have to find y prime plus 3y. Y prime is negative 3a e to the negative 3x plus 3 times y. Y is basically this expression, a e to the negative 3x. Negative 3a e to the negative 3x plus 3a e to the negative 3x is 0. These two expressions are negative of each other, and so their sum is 0. And this completes the solution of this question. Now look at this question. Find the values of r such that the function y equals e to the rx satisfies the differential equation y double prime minus 2y prime minus 4y equals 0. First, we have to find y prime and y double prime. The y is given e to the rx. For finding y prime, we use the chain rule. Derivative of the exponential function e to the sum function, sum expression, is e to the rx. Remember that derivative of e to the power of any expression is itself times by derivative of the exponent because of the chain rule, times it by derivative of that expression. Now we use this rule for finding derivative of e to the rx. So derivative of e to the rx is e to the rx times by derivative of the exponent. What is derivative of rx? Derivative of rx is just r. Like derivative of 5x is 5, derivative of 2x is 2. So derivative of rx is r, because r is a number, is a constant. Now we have to find y double prime. For finding y double prime, we don't need to use the product rule. Attention, here r is a constant. Only we have to find the derivative of this part, and then we have to multiply derivative of this by this constant. So derivative of e to the rx is e to the power of rx times by r, because derivative of the exponent, derivative of rx is r. And don't forget to multiply this by the r that we have here. So y double prime is e to the rx times r, which we can rewrite this as r to the 2 e to the rx. And also you can write this in the form of r e to the rx. Now that we have y double prime, y prime, and y, we have to substitute these expressions here in this differential equation. We have to set it equal to 0, and from that we are going to solve it for r to find the value of r. Y double prime is r to the 2 e to the rx minus 2 times y prime. Y prime is r e to the rx minus 4 times y, minus 4 times e to the rx equals 0. Now we have to solve this differential equation to find the value of r. If you look at these three terms here, we can see that e to the rx is common between all of them. If we factor e to the rx, we have r to the 2 minus 2r minus 4 equals 0. From this, we can conclude that the first expression should be 0, or the second expression should be 0. But attention, the exponential function e to the rx is never going to be equal to 0. When we have e to any power, exponential functions are always positive. Remember, graph of y equals e to the x. For every value of x, the exponential function is always positive. Its graph is above the x-axis. So it doesn't matter what is the expression here. E to any power is always positive. So the first expression here, this expression, is never going to be equal to 0. Because this is not equal to 0, so the bracket should be equal to 0. And by solving that equation, we can find r. So r to the 2 minus 2r minus 4 equals 0. For solving this quadratic equation, we can use factoring method, completing the square method, or quadratic formula. But because factoring this quadratic expression is a bit difficult, it's better to use the quadratic formula. If you want to factor it, you have to find two numbers that their product is -4 and their sum is -2. And because the answers of this question are not integer numbers, so forget factoring for finding r. And it's better to use the quadratic formula for finding r. Let me remind you the quadratic formula. When we have ar to the 2 plus br plus c equals 0, r equals -b plus minus square root b to the 2 minus 4ac r over 2a. If we use this formula, r equals 2 plus minus radical b to the 2, 4, minus 4 times a times c all over 2a. So r equals 2 plus minus radical. Inside the radical we have 4 minus -16, so for 4 plus 16 it's 20 all over 2. So the r values that make this function a solution for this differential equation are those numbers. If you want, you can simplify this answer that we got here. If you attention, we can write 20 in the radical as 4 times 5. Radical 4 is 2, so we can write it as 2 plus minus 2 radical 5 over 2. Now we can write this answer as 2 divided by 2 is 1 plus minus 2 radical 5 divided by 2 is radical 5. So this answer is the same as this, but this is more simplified, and it's better to simplify your final answer. So the values of r that make that given function a solution for the differential equation are these numbers: 1 plus minus radical 5. Now look at this question. Show that the function y equals e to the 3x times by a cosine 2x plus b sine 2x satisfies this differential equation y double prime minus 6y prime plus 13y equals 0. To show that this function is a solution for this differential equation, first we have to find y prime and y double prime. So we have to find the first derivative and the second derivative of the given function. Y equals e to the 3x times by a cosine 2x plus b sine 2x. First we have to find y prime, the first derivative. For finding derivative of y, we use the product rule because we have a function times by another function, so we use the product rule. Let me remind you product rule. If we have f times g and we want to find the derivative of the product of these two functions, the derivative equals f prime times by g plus f times by g prime. So y prime equals, take derivative of the first function, derivative of e to the 3x. Derivative of e to the 3x is itself times by derivative of the exponent 3. So derivative of e to the 3x is 3e to the 3x. It's better to write this 3 in front here. So derivative of the first function is 3e to the 3x. 3e to the 3x times by the second function plus write the first function and multiply this by derivative of the second function. What is derivative of a cosine 2x? When we want to find the derivative of this function, a is a constant, is a coefficient for this. We keep the a and we have to find the derivative of cosine 2x. The derivative of cosine is negative sine. So derivative of cosine 2x is negative sine 2x. But don't forget to multiply by derivative of the inside. Cosine, derivative of cosine is negative sine. This is the outside function, derivative of the outside function. But you have to multiply by derivative of the inside function. And derivative of 2x is 2. So we have to multiply this by 2. So derivative of a cosine 2x is negative 2, put the 2 here, negative 2a sine 2x. Negative 2a sine 2x plus, now we have to find derivative of b sine 2x. Again, keep the b. Derivative of sine is cosine, multiply by derivative of the inside 2. And again, if you put the 2 here, derivative of b sine 2x is 2b cosine 2x. 2b cosine 2x. Now we have to find y double prime. If you want, first you can multiply the 3e to the 3x in the bracket. You can multiply e to the 3x in the bracket, and then you can find y double prime. But here I directly want to find y double prime from y prime before simplifying this. Again, we use the product rule here. First, we have to find the derivative of this. What is the derivative of 3e to the 3x? The derivative of 3e to the 3x is, keep the 3, its coefficient. Find the derivative of this. The derivative of e to the 3x is e to the 3x multiplied by the derivative of the exponent 3. 3 times 3 is 9. So the derivative of 3e to the 3x is 9e to the 3x. Times it by the second function. So times by a cosine 2x plus b sine 2x. Plus write the first function 3e to the 3x times it by derivative of this. What is the derivative of a cosine 2x? For finding the derivative of a cosine 2x, again, attention, a is a constant. Just you have to find the derivative of cosine 2x. And the derivative of cosine 2x is negative sine 2x. And the derivative of 2x is 2. So finally, what is the derivative of a cosine 2x? Its derivative is negative 2a sine 2x. Also, we got the derivative of a cosine 2x here. So it's the same answer as you can see. Plus, what is the derivative of b sine 2x? We got the derivative of b sine 2x here is 2b cosine 2x. Plus, now we want to find the derivative of this. First, we have to find the derivative of e to the 3x. The derivative of e to the 3x is e to the 3x times 3, which we write it 3e to the 3x. Always it's better to put the coefficient, the number in front, times by the second function itself, negative 2a sine 2x plus 2b cosine 2x, plus write e to the 3x and multiply this by derivative of this. For finding derivative of negative 2a sine 2x, keep the negative 2a, find the derivative of sine of 2x, its derivative is cosine 2x, and multiply by derivative of 2x 2. 2 times negative 2a is negative 4a. So it is negative 4a cosine 2x. And if you want to find the derivative of 2b cosine 2x, so if you want to find the derivative of 2b cosine 2x, keep the 2b. Derivative of cosine is negative sine. Don't forget to multiply by derivative of inside 2. 2 times negative 2b is negative 4b. So its derivative is negative 4b sine 2x. Now that we have y double prime, y prime, and y, we have to substitute these expressions here, and we have to show that if we simplify it, we get 0. So y double prime minus 6y prime plus 13y equals 0. So we want to prove that y double prime minus 6y prime plus 13y equals 0. Before I write all these expressions here, attention that in y prime and y double prime, all the terms, if you look carefully, have something in common. E to the 3x. E to the 3x is everywhere. All the expressions have this e to the 3x. So we can factor e to the 3x in the beginning, and just we need to write the rest. So we factor e to the 3x, and now when I want to write y double prime, I am going to write everything except e to the 3x because I factored it in the beginning. So y double prime would be 9 times a cosine 2x plus b sine 2x. Attention, we factored this, so we have to write only 9 and this bracket. From this, because we factored e to the 3x, we have to write 3 times this bracket. But if you look at here, this and these are the same. And we have a 3 here and a 3 here. 3 plus 3 is 6, and these two expressions are the same. So we can write plus 6 times negative 2a sine 2x plus 2b cosine 2x. And finally, from this we only have to write this because we factored e to the 3x. So plus negative 4a cosine 2x minus 4b sine 2x minus 6y prime. So minus 6 times by y prime. Y prime is this. If we multiply this negative 6 by this and this, we have to write it here. So minus 6 times y prime. Don't forget to multiply negative 6 in both of the terms. Negative 6 times this 3 is negative 18. So basically we have negative 18 times a cosine 2x plus b sine 2x. And don't forget to multiply that negative 6 by this expression. So we have minus 6 times negative 2a sine 2x plus 2b cosine 2x. And finally, plus 13y. So plus 13 times y. Y is this expression, but we factor this, so we have to write only a cosine 2x plus b sine 2x. And don't forget to close this bracket that you opened here. You have to close it here. Now if we simplify this expression inside the big bracket, we have to get 0 because we want to prove that y double prime minus 6y prime plus 13y equals 0. So it should be 0. But let's see, can we get 0 or not? So again, I'm going to write e to the 3x outside and then multiply 9 in the bracket. Then you have 9a cosine 2x. First, let me write all the terms with cosine. If we move here, we don't have any cosine. Here we have a 2b cosine 2x, but if we have a 6 here, so we have plus 12b cosine 2x. Then we have this term minus 4a cosine 2x. And we have this term minus 18a cosine 2x. We have this term negative 6 times this plus 12b cosine 2x, and finally we have this 13a cosine 2x. Now I am going to write the terms with sign. 9 times b sine 2x, 9b sine 2x. Then we have negative 12a sine 2x. We have minus 4b sine 2x minus 18b sine 2x plus 12a sine 2x, and finally we have 13b sine 2x. So let's simplify the inside. We have 9a cosine 2x minus 4a cosine 2x minus 18a cosine 2x plus 13a cosine 2x. 9 minus 4 is 5. 5 minus 18 is negative 13 plus 13 is 0. So these terms cancel each other. 12b cosine 2x, the other one should be probably negative 12b. Yes, this should be negative. Attention, if you multiply this negative 6 by 2b, we get negative. So this is negative. Here is negative. So here is a negative. So these two cancel each other. Now look at the sine terms. 9b sine 2x minus 4b is 5. 5 minus 18 is negative 13 plus 13 cancel each other. And finally, negative 12a sine 2x plus 12a sine 2x is 0. So we have e to the 3x times 0, and this is 0. And this completes the solution of this question. So we proved that this function is a solution for this equation. I hope you liked this video, and see you in the next videos.